Welcome to this data statistics. Today we are going to discuss very important topic uh, that is stratified random sampling. An important objective in estimation problem is to obtain an estimator of a population parameter which can take care of all certain features of the population. So here a stratum means the group of observations are divided. A homogeneous group of observations are can be classified into some group of observations. So here the population is homogeneous with respect to the characteristic under the study. Then the sample drawn through the simple random sampling is expected to provide a good representative sampling. So here we can see that the homogeneous group of observations the population is homogeneous with respect to the characteristic under the study. So then this method is a very good method estimator to population mean. So here are some features of this stratified random sampling. Generally, if you consider any example, then you can easily see this and easily understand the systematic and stratified random sampling. In order to find the average height of the students in a school of class 1 to 12, the height varies a lot as the students in a class 1 are of age around 6 years and students in class 10 are of age around 16 years. So, one can divide all the students into different subpopulations or stratas such as student of class 1 to 3 is one stratum. So we are dividing one stratum. We are using some group of homogeneous group of observations over here. So similarly, students of the class 4, 5, 6 that stratum 2. Similarly, the students of class 7, 8, 9 of stratum 3. Again, we are classifying another students of class 10, 11, 12 as stratum 4. Now, draw the sample by SRS from each of the strata 1, 2, 3, 4. All drawing samples combined together will constitute the final stratified sample for further analysis. So here are some notations for this sampling. Capital N is the population size, K is the number of stratas. Here Ni denotes the number of sampling units in ith strata. So here the strata defines is as a stratum. Okay. So capital N, which is equals to the summation of all the observations, Ni, the number of sampling units to be drawn from the ith stratum. So these are the sample size K. So here the smaller n is a total sample size. Similarly, the procedure of stratified random sampling and a difference between a stratified and a cluster sampling schemas or skills you can see over here, and which is very important task in our stratified random sampling is estimation of the population mean and variance. Estimation of the population mean and its variance. So these are some formulas so which you have to understand very clearly, and let us see. Okay, the population means total population units are we are denoting with the capital N, and a stratum 1, stratum 2, stratum K, we can divide them. From the stratum 1, we are drawing the sample size of N1 units. From the stratum 2, we are drawing the sample. Like that, we should continue. This is a combined picture of the stratified random sampling. Okay, for which you can easily understand. So the estimation of the population, this is very, very important task and very, very important theorem. So in SRSWO or in SRS simple random sampling, if you can call it in short form as S or S. Okay, the estimation of the population mean. First we discuss the estimation of the population mean. So that is a small number of N. If you apply expectation over here, then you're going to get the population mean. So here the sample observations mean is this one, and the population observation mean is this one. So you can easily understand these things. Okay, so since the sample in each stratum is drawn by SRS, so expected value of small y bar of I is equals to y bar of capital Y bar of I. So which you have to show here. So here, if you apply the expected value, what is the formula of that? That is n into expected value of y, expected value of y bar of I. So which is equals to is in the form of capital Y bar. So on solving, which we can easily find out that the expected value of small y bar is equals to the capital Y bar. Okay, so this is one of the important theorem in stratification. Yes. Similarly, variance over here also you should see variance of y bar of ST. ST in a sense the stratification, stratified random sampling. SRS. Since covariance of y comma y bar of I comma y bar of j is equals to 0, the variance of y bar of I is equals to capital N minus small n divided by ni into ni of Si square, where Si square is the sample mean square, where Si square is the sample mean square by E. Thus, can easily understand. So this is a very complete picture of the variance. So this is one of the formula which you are going to use. Okay. Yeah. Next, estimate of variance also. Sample value. An advantage of stratified random sampling if you want to quote in your answer. Okay, this is the end of the slide. So which you can easily known about this advantages of stratified random sampling. The data of known precision may be required for certain parts of the population. This can be accomplished with a more careful investigation of a few strata. So that is one of the advantage. For example, in order to know direct impact hike in petrol prices, the population can be divided into the stratas like lower income group and middle income group and higher income group. Obviously, the higher income groups is more affected than the lower income group. So more careful investigation can be made in higher income group strata. So how it is varies, we can easily observe by this stratified random sampling by applying. Next, sampling problems may differ in different parts of the population. To study the consumption pattern of households, the people living in houses, hotels, hospitals, prisons, etc. are to be treated differently. So they are the homogeneous people. We are dividing them, the total population, into some group of homogeneous observations, so which we can call it as a stratification. Okay, this is one of the best example. Okay, to know about that, which we can divide, okay, into the status. Administrative convenience can be exercised in a stratified sampling. For example, in taking a sample of villages from big state, it is more administratively convenient to consider the districts as status, so that the administrating setup at the district level will use it for this purpose. Such administrative convenience and convenience in organization of field work are important aspects in national level surveys. Yeah, now we have a lot of examples for this stratification, stratified applications. Okay, which you can easily see over here. So this is one of the applications which we are discussing. Okay, that is the end of this slide. So thank you.